Let's do some simplifying of complex numbers. So every complex number can be written in standard form, which is like this. So what I want to do for this number is FOIL it out. I'm going to write it like that, plus 4i. Now I'm going to distribute the 9 into both of those and the 4i into both of those. So this is going to equal 81 plus 36i plus 36i plus 16i squared. Remember, I squared is just -1 because I is equal to the square root of -1. So I squared equals that squared, etc. So this just equals 81 plus 72i, because those are like terms, right? Minus 16. And that equals what? 65 plus 72i. That's what this equals in standard form. Let's try another one. All right, notice I'm now subtracting two complex numbers. See how these are both written in this form here, standard form? So I'm subtracting them. So in order to subtract them, this is just algebra. I distribute that negative in and I add like terms. What's 6 minus 5? That's 1. What's -2 plus 7? Positive 5i. And that's done. Notice how, again, that's in standard form. A is 1, B is 5. Let's try another one. 2 plus 5i times 2 minus 5i. Notice when I FOIL this out, I'm going to get 4 minus 10i. And then when I continue foiling, I would get plus 10i minus 25i squared. And what happens to your middle terms? Those cancel each other out. And what does this turn into? -1. So that's just 4 plus 25, which is just 29. So amazingly, I started with two complex numbers, but when I multiplied them out, I got a real number. And that happened because they're conjugates of each other. I knew that would happen when I did it, because the imaginary part canceled out. So that's a trick to remember whenever you're trying to get rid of complex portions or radicals. That's multiplying by the conjugate is a trick that carries all the way through calculus classes.